Welcome, class. This session is about real options. This is adapted from a article I read by Greeley, Meyer, and Allen, and they're experts in real options. And I want to show you what the value of this is. We're all familiar from our studies about net present value. And here's a little capital budgeting problem that I have on the screen, and it shows. There's an initial evaluation done in 1982 on the Mark I microcomputer, and it takes a $450 investment to get started, and then it's going to throw out these cash flows for each of the next several years. And then if we calculate our net present value, well, normally what we would say here is we're going to reject this because this is negative, according to the NPV decision rule. But not so fast. Decisions in the real world are not that clear cut, and sometimes there's other things that are on the horizon that we need to look at besides just saying, well, the net present value doesn't look good. What else could come out of this? Okay, well, you can see over here I have an evaluation for an add-on for the Mark II. And in this case, we'd have to invest another $900 sometime just before 1986, and then we're going to get these additional cash flows. And what this amount here represents is the present value of these cash flows, and the net present value is the $92.89. And again, it's not so good. So why even bother to look at this? Well, cash flows aren't always all that certain. So what happens if this turns out that we get more than this 900 in capital investments? So let's say there's a volatility here of 35%. In other words, the cash flows can vary from the mean values by 35%, which means that our results can be significantly different if they do. So I'll show you a way to use options, call options to see what this would be worth. Okay, so we want to get our arms around this net present value evaluation. We know we've got a negative net present value, and according to the decision rules for net present value, ordinarily we would reject the project. But we have this other project here on the horizon, specifically starting here in 1986, and again, it doesn't look good. But what happens, we're so far out, could this turn around and generate more of a cash stream to exceed this 900? Well, we don't know. We have a 35% variability, and there's a good chance that it could turn around. And so we want to know, if we don't do this, are we going to lose out on the potential upside from the second add-on here? So we can use an option model, a call option model, in order to make that evaluation. So let me call up a Black-Scholes calculator from the web, and I have one right here. And you can see here the first thing that it asks for is a current share price. And this is because normally this is used to value stock options. Okay, well, we're not talking about stock options here. We're talking about projects, capital budgeting projects, and we want to evaluate them. So what we need to know is what is the value of the potential value of the second add-on cash stream. And here we calculated the present value as of 1986. And if we want to take it back to the start, all the way back to 1982, we did that down here. And this really isn't a negative because this is not net of any investment or anything. So this should be a positive. It's just that, that's the way I calculated it. Okay, so we're going to put that in on our Black-Scholes calculator. We had 467. was '07. If not, I can come back and fix it later. And we also had our investment of $900, which is the same thing as a strike price. In other words, we have to get over the $900 investment in order to exercise the option. Otherwise, we're back to where we were here with this negative 92.89. So in order for this to work, we have to at least have a cash stream over these 4 or 5 years, whatever they are here, that exceeds that $900. So our strike price is $900 for purposes of this calculation. And since we're going back to 1982, we've got a 3-year option basically. So we've got 3 years from 1982 to 1986, the start of 1986. And the problem gives us a risk-free interest rate of 10%, and we know our volatility is 35%. So if we hit calculate, it's going to give us an option value, and notice it says European call value, and that's okay because what a European call value is, it means it's at the end of the option period, where an American call value would be any time. It could be calculated any time up to the end of the call period. So this tells us that this option is worth 56.86. So let's go back to our spreadsheet and put that in here. 56.86. That's, and we'll label that. That's our call value, call option value. Okay, and if we now net these out, we have an adjusted present value of 1041. And what does that mean? Okay, so here we had a negative net present value. We clearly reject the project, but we don't know about this thing out here that starts in 1986. Is it worth anything? Well, it's kind of fuzzy right now. So in order to determine, if there's any potential value, we want to have a call option. And so the value of this thing is 56.86, which is positive. And if we net against that, the present value, or the net present value that we calculated up here for the Mark I project, we've got an adjusted present value of 1041. This time it's positive. So we might want to wait and see and then be able to exercise this option, because this could generate a whole bunch more in cash flows than we anticipate right now. So basically that's it in a nutshell. Options give you further courses to evaluate that you wouldn't ordinarily evaluate if you didn't have the option to wait, or if you didn't have an option later on to abandon or change the mix of your projects. So that's what the value of this is. The call option gives you the opportunity to wait, the ability to see how future cash flows develop that you wouldn't have if you didn't have the option. So I hope you found this valuable, and this should really simulate more of what the real world is really like. Thanks for listening.